Every atom have been revolving their orbits for 15 billion years, yet never colliding with each other. Who maintains such an order within such a small realm?
Yeah, so when we think about the electrons going around the atoms, this is actually one of the things that historically persuaded people that quantum mechanics was true. Because if you think of the electron as just this little billiard ball orbiting around the nucleus, sort of like the way the Earth orbits around the sun, the problem with that is as the electron moves, it would be radiating energy away, and eventually it would lose all of its energy, and it would fall into the nucleus and crash. So just if we have a satellite around the Earth, none of them stay up there forever. They all eventually run out of energy and fall down and burn up in the atmosphere. So there was a big question in people's minds, why doesn't that happen with the electrons orbiting the atoms? And the answer turns out to be quantum mechanics, that the lowest resonance of the electron around the atom has a certain wavelength, and it corresponds to a certain distance of the electron away from the nucleus. And it simply can't go any lower. So in sort of a musical analogy, you could say, if I'm playing a musical instrument, there is one lowest note that I can play on that musical instrument, and I can't go any lower. And we would call that the fundamental resonance. And something very much like that with the electrons around the atoms. So you could say that the system of quantum mechanics keeping the electron stable is really another place where God intervenes to make the laws of physics work so that things allow us to exist and so on. If it was a purely classical world, then actually we couldn't exist because the electrons would just fall into the nuclei. Again, when we talk about fine-tuning parameters, one of the parameters that is extraordinarily important is Heisenberg's, the Planck constant, which determines the length scale over which that quantum mechanics applies. And if that was too large, then we would have really weird quantum mechanical effects, and if it was too small, then other bad things would happen. So quantum mechanics actually is another example of a fine-tuned theory that allows things to be stable.